surface of the Moon is made primarily of what is called regolith, a layer of loose rocks, dust and other material. The thickness of the regolith varies from about 5 metres in the mare regions to about 10 metres in the highland surfaces. Although regolith can be found on Earth, lunar regolith is fundamentally different. The majority of the surface is a layer of fine grey soil and dust a few centimetres deep, made of 5 basic particle types: crystalline rock fragments, breccia fragments, mineral fragments, different types of glass, and agglutinates, a unique lunar particle. Impacts by micrometeorites and rocks over billions of years breaks up particles on the surface, forming smaller fragments, and can also cause fragments to become cemented together, forming what is called breccia. Impacts can also melt parts of the soil, and this melted soil can mix with other particles, forming irregular clusters called agglutinates. Lunar dust is a serious hazard to humans and machines on the surface. Due to the absence of an atmosphere and fluid erosion on the Moon, the dust particles maintain their sharp edges gained from the high-velocity impacts, resulting in very abrasive properties. Solar winds and cosmic rays impart a photoelectric charge into the dust particles, and this charge, along with the fact that dust has a low electrical conductivity, allowing individual grains to remain electrostatically active, means that the dust will levitate, crawl up and adhere to surfaces. The dust can easily creep into seals and joints, rendering critical equipment inoperative. The dust is also toxic if breathed, and is covered in chemically reactive bonds that would otherwise be neutralized on Earth by interaction with atmospheric oxygen. The concern about the dust is that it can enter the lungs, interact with the blood, and kill cells throughout the body. The reduced gravity keeps the fine particles suspended in the airways for longer, allowing them to get deeper into the lungs and reach the bloodstream. To reduce the risks, sheaths for machines and robots will need to be designed to keep the moving parts and joints clear of the dust. Structures and delicate equipment can be placed at least a metre above the surface, and the surface around any facilities could be microwaved to create a smooth melt. Habitats need to be overpressured around the openings to prevent the ingress of dust, and astronaut suits must be carefully designed for the same reason. We can, however, learn to use a lunar regolith in many different ways. It could be soil for growing plants, it contains all the necessary ingredients for making concrete, and it could be sintered to create building blocks. It can be used as a feedstock for 3D printing parts, and its major component is oxygen, which could be extracted. Before we can benefit from the lunar regolith, we must first learn to safely work with it. The problematic nature of the lunar dust was discovered during the Apollo program, and now, looking to future lunar missions, it must be carefully considered so its impacts are limited.
Let's press on and help Jack.
I'll just come and help you. Okay. Okay. Yep. Remind me to dust my camera too, will you?
Okay.
Don't forget to dust your camera.
We'll keep track of that for you, see.